coming from the research side, but very much driven by applications, I think the first thing I would say is being end user driven. And I think we've heard that a lot. And I think what we see a lot on the research side and the technology on remote sensing, and of course, remote sensing is so incredibly applicable for AI, and we're seeing massive advances there. But if I'm sitting on one side of the world developing fantastic research on how do I map the world's croplands, or how do I forecast drought, or what are the implications of a particular drought on yields, and I'm not talking to the government or the user or whatever organization is actually on the ground and can have an impact, they're not going to use it. Right. And I think we see this over and over again. And so in order to be able to advance technologies and integrate them, they've got to be end user driven. They've got to be ready for whoever it is that's supposed to be using them. And really, really important, and I think we've heard that throughout the day, is co-development, right? And so that what you're developing is actually in response to what is needed, making sure that ownership is with that organization or with those users that are actually going to then take it on and use it, because you also have accountability. And if you have a government that's then going to make a decision on that data, and you're a researcher sitting in whatever country you can choose, you're not responsible, actually, right? Like, you can have errors in the data sets and you're not going to take that accountability. Yet whoever it is that you're giving that to has to take the responsibility to take the actions on that, right? So I think I can't emphasize enough how important that is, that research and technology and all these applications that we're driving are done collaboratively. They're done in response to what is needed, and that there's transparency around the things that we're developing. I think we are advancing so quickly in our capacities. I think, obviously, I sit very much on a remote sensing side and an agriculture perspective. But every year, the advances in terms of what we can do with satellite data, what we can do with advances in machine learning and applications is massive. The accessibility to a lot of this kind of information and data and platforms is so wide now. At the same time, what that means is that we have a responsibility as data producers to make sure we're transparent about the accuracies of our models, right? If you run a product, you'll always get an answer on your model. But what's the accuracy of that, the model that you've created? And what we're seeing is tons of products being out there, but they're not properly validated. We don't understand how to properly use them. And I think there's a lot more communication that needs to happen about, what does my map mean? If I'm showing deforestation, what is my accuracy in particular locations? How can a user start to actually understand and translate these massive amounts of data that we have into actionable information? And I think there's a lot more work that needs to be done also across communities. And I think, we're still very siloed. I think, we talk to agriculture ministries, and then there's the Met industries. And when we're talking about early warnings, these are all actually really integrated, right? And how do we better think about bringing together communities and bringing these kind of information together? And I think here I'm just showing one example of the types of information we can produce from satellite data. In this case, I'm focusing on different agricultural information. Then when you bring these kinds of information together, you can assess risks really well when there is a disaster, whether it's a flood, a drought, any kinds of extreme weather events, crisis, right? Well, your questions are, if you're going to activate an early warning system or a response system, is, well, where are my people? Where are my croplands? Where is my infrastructure, right? And so looking at how can we advance those kinds of products, but doing them in collaboration, in contact with users and with communities that are going to use them. I think the part of that is, of course, building local capacity. And again, we've heard that over and over again. And so I think we've got to also make sure that the technology is adapted to the user that's going to take it on. And so if I've got a really complex, very heavy computational model, well, and that's not going to work. So how do we look at what are those areas where it's actually going to match what the capacities are on the other side, and making sure that then we can do that transfer. And I think with that also comes a sense of, how do we do long-term and sustained building of capacity and building of these kinds of technologies and projects. And I think oftentimes we see a lot of pilot studies, right, and feasibility studies, and we all do those, and we have a 3-year project, and we've built trust within a particular government or community that we're working with, and then we say, oh, sorry, our funding is out, we're now leaving. And actually, you do a lot more harm when you do that. And so finding ways in terms of how do we maintain long-term vision and goal, and making sure that we are designing programs and systems that can get us there. And here I'm showing an example of using satellite data, but also very much in a community and consensus-driven way. And so this is what's called the GEOGLAM Crop Monitor. We have actually 2 operational products that come out every month. One is a crop monitor for early warning, very much focused on those countries most vulnerable to food insecurity. And then, of course, those countries that are the main producers and exporter countries of the world. And this map is supposed to be actually very much policymaker facing and give a very quick sense globally around the world. What do crop conditions look like? And I think the main thing, and this is our last month one, our next one's coming out actually later this week, so there'll be some changes here. But the main thing actually that pops out is all these areas around the world that are yellow or red, right? And those are the area, if you're thinking about early warning, I better be monitoring these areas much more carefully because there is a potential there that we are going to have crop shortfalls. What are then the implications? How many countries is those main producer, exporter countries that might have implications in terms of global markets, or is it more regional or national or localized? And oftentimes what these maps do and information does is then helps us to dive deeper into a particular location, do a deeper analysis of those. But these are made with 40 different organizations that participate in this consensus building on a monthly basis with a lot of satellite-driven information, but a lot of global, local information, and of course, a lot of domain expertise. And that's always so important, I think, in everything that we do, is making sure that we have teams that are integrated, that we have the computer science and the AI, but the agriculture and the local context and the climatologist, right? And I think those are, I'm saying a lot of obvious things, but we don't quite see that, I think, often enough. Next slide. Oh, and I'm on 1 minute. Okay. So, a different example is we've done a lot of work on the Ukraine war, for example, trying to understand and assess how much of an impact did that have on agricultural production, in particular in occupied territories. And again, this is where satellite data often is going to be the only source of information that we can actually have to assess what's happening on the ground and assess that at scale. So here's a map of across the country of last year in terms of all the crops that were grown, where they are. We then did a lot of other analysis to estimate what the production was, but this is being carried out with the State Statistical Service, right? And so we're now in the process of transitioning this capability to the State Statistical Service, who can then carry on with this kind of work. Next slide. Do one more? Okay, great. Another example is working with FAO and the Ministry of Agriculture in Malawi, and this was during Cyclone Freddy in 2023, where we worked with them to develop cropland maps and then look at the flooding areas, and they then designed on top of that a more efficient way of going and sampling on the ground to understand what the implications of the cyclone were, how much crop damage was there. And so again, an integrated approach in terms of both the satellite data actually helping to then make survey on the ground data more effective and efficient. And maybe I'll stop there. I could go on for a long time.